projectiles, inclined plane. Type 1, max height, range and landing speed. So I've chosen this question because of the way the angles are given to us in the question. And it's always really important to remind you of how to deal with angles when they're given to you in the form of tan inverse rather than alpha equals or theta equals or beta equals. So if I look at the first angle there, the angle of the inclined plane, then what we have is alpha is equal to tan inverse of 3 over 4, so the angle of projection with respect to the inclined plane, and beta is equal to tan inverse of 5 over 12. So basically both of those can be written as tan alpha equals 3 over 4 and tan beta equals 5 over 12. So what we can do with both of those now is actually draw our right angle triangles for alpha. So we have opposite over adjacent for tan, and then obviously that's our 3, 4, 5 triangle. And then for beta, we have opposite over adjacent, so 5, 12 and 13. So again, just using Pythagoras there to get your h squared equals o squared plus a squared. But as an applied maths student, you should know that off by heart now, really, at this stage. So I don't really need to show you Pythagoras. I'll just mark in there we have our opposite, our adjacent and our hypotenuse. Okay, so what that then allows us to write down is what sine alpha is. Opposite over hypotenuse, so 3 over 5, whereas sine beta is again opposite over hypotenuse, which is 5 over 13. Cos alpha is adjacent over hypotenuse, so 4 over 5, and cos beta is adjacent over hypotenuse, which is 12 over 13. So therefore we're going to use these to complete our table for U, A, B and S. So before we look at filling out that table, we want to have a look at and see what is it they're actually asking us to do here. So we're given the initial speed is 10 meters per second. So speed meaning that's the magnitude, and we have to work out what u in the x direction is and what u in the I direction is, remembering that u, the vector, is going to be u cos alpha in the I direction plus u sine alpha in the j direction. And it wants us to then basically find the range. So on landing, how far has it moved from its original starting position on the inclined plane? And then we also want to show that after 2/5 of the time of flight, the distance along the line of the inclined plane through which the particle has travelled is 28 over 55 of the range. Okay, so we're going to start by completing the table. So you're going to pause the video here and you're going to draw out the table and filling in all of the values, and then press play and see have you got the table filled out correctly. Okay, so it's important to note that our u was equal to 10 meters per second. Okay, so if we're looking at the first one, it's going to do the rough work down here at the bottom before filling in the table. So u in the x direction is equal to u cos alpha, but we know u is 10 and cos alpha is 4/5. So therefore that gives us 8 meters per second going in to u of x, and u of y is equal to u sine alpha, and again that's going to be 10 by sine alpha we worked out was 3 over 5, which is going to be 6 meters per second in the y direction. So we say u in the y direction is equal to 6. So a in the x direction then is minus g sine beta, and sine beta we saw was 5 over 13. So therefore that gives us minus 5g over 13. and a in the y direction is equal to minus g cos beta, and cos beta was 12 over 13, so that's minus 12g over 13. So of course then we know that v is equal to u plus at, and s is equal to ut plus a half at squared. So we just need to fill in those two formulas with respect to the x and the y axis. So v in the x direction is u plus at, and v in the y direction is u plus a t. S in the x direction then is ut plus a half at squared. So a half of 5g, well that's going to be 5g over 26 t squared. And S in the y direction is ut plus a half at squared. So half of 12g over 13 is 6g over 13 t squared. Okay, so now we have our table filled out. What we now want to look at is how can we find the range. So to find the range, we know that that is the biggest distance it can travel from the starting point, and that occurs when sy is equal to 0. So in other words, we're going to need to work out our time of flight and then sub back into this equation here for s of x. So I'm going to move on to the next page. So you can just rewind the video if you need to go back to the table, but you'll have your table written out anyway. So we say the range s of x occurs when sy equals 0. So we take our equation for s of y. So that was 6t minus 6g over 13t squared. So if we write that out, then we have sy is equal to 6t minus 6g over 13t squared, and we're going to let that equal 0. So if I factor out my t, that leaves me with 6 minus 6g over 13t equals 0. And if I let both of those equal to 0, then I get t1 is equal to 0, or 6 minus 6g over 13t equals 0. In other words, we have 6g over 13t equals 6. And remember, left to right equals right to left there, or else you're multiplying both sides across by minus 1. And then I can see that the 6's cancel, leaving me with t is equal to 13 over g. So in other words, the second time when sy is equal to 0. And of course, that's on landing. So in other words, if I look at this diagram here on the left, there's the initial velocity. Actually, sorry, I'll just undo that diagram because it's the inclined plane. Sorry, I'll just redraw that. So as it's going up, we'd say from start, that's its starting point, it's starting on the inclined plane, and then it lands on the inclined plane. So the height above the inclined plane is 0 on landing and also at the start. So that would be at t1 and that would be at t2. And of course we're looking for the range, which is this value, the distance between those 2 points there. So of course we just simply take that time, this is our time of flight, and we're going to find the range when t is equal to 13 over g. So our equation for s of x was 8t minus 5g over 26t squared. So if I sub in for my t, I have 8 times 13 over g minus 5g over 26 times 13 over g, and be careful there, a lot of students will forget to square the 13 over g there. And if you multiply that out and simplify, you want to generally get your answer in terms of g. So of course subbing in that into your calculators, what do we end up with? So of course 8 times 13 is 104 over g, and if I have 5 times 13 squared over 26, then I'm left with 65. And of course I have g over g squared, so that's 65 over 2g, because the g goes into the g squared once. So my lowest common denominator there is 2g. So if I multiply the top and the bottom there of 104 over g by 2, I get 208 minus 65 all over 2g. So S of x at the time of flight is 143 over 2g. So in other words, this is my range. So if I just go back to the original question there, just to point out that the range was in terms of g there for our answer, okay? I'll just rub that out. So it's in terms of g. So we must make sure the g isn't written as 9.8 there in the question. So the whole way through it's in terms of g. So the second part of the question says, show that after 2/5 of the time of flight, the distance along the inclined plane is 28 over 55s of the range. So what we want to look at next is 2/5 of the time of flight. So 2/5 of the time of flight, well, that time of flight was 13 over g. So therefore the time is going to be 2/5 of 13 over g. In other words, it's going to be 26 over 5g. So therefore I need to work out the distance travelled during this time. So f of x when t is equal to 26 over 5g. So if I sub into my s of x equation again, well, s of x was 8t minus 5g over 26 times t squared. So of course if I sub in for my t, that's going to be 8 times 26 over 5g minus 5g over 26 times t squared. Well, it's 26 over 5g squared. Now what's nice there is that we have 5g over 26 times 26 over 5g twice. So clearly that's going to go in once. So we're going to multiply the 8 by 26, which gives us 208 over 5g. And 26 will go into 26 squared 26 times. And 5g will go into 5g squared 5g times. And of course that is our lowest common denominator, 5 over 5g. So we have 208 minus 26 then gives us 182 all over 5g. So basically we have to now show that that is 28 over 55 of the range. Well, our range was equal to 143 over 2g. So therefore if I get 28 over 55 of the range, well, what does that simplify down to give? So we have 28 times 143 is 4004. And we have 55 times 2 is 110 over g. And 4004 over 110 simplifies down to give us 182 over 5g. So in other words, 28 over 55 of the range is equal to 182 over 5g, and therefore we can see that both of these are the same. So we say hence equal, which is what we wanted to show. Okay, so what you're going to do for me now is you're going to go to your book, page 182, or else on the sheet which I've attached in Edmodo. And you're going to do for me in that exercise question 1. You're going to do question 6 on page 183. You're going to do question 7 on page 183. And yeah, that's it. So I'll just call that out again. You're going to do question 1 on page 182. You're going to do question 6 on page 183 and question 7 on page 183. And any issues, please just ask me. Don't ask me next Friday. Ask me before that, because obviously if you have a problem with the question, somebody else might have a problem with the question. And by me posting the video of the worked out solution might help more than just you. Okay?